A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm the same. Thank you. So, hello, a very warm good morning to all of you, and welcome to Byju's Exam Prep IS. Welcome to the second session of Geography, where from today we shall be picking up the threads that we left off yesterday, and then we shall be entering into the portion of geomorphology in particular. So, what is it that we looked at yesterday? So yesterday when we were talking about the various different aspects, the very basics. So we basically talked about the Big Bang theory, that what is the Big Bang theory, the theory of expanding universe that was provided by Edwin Hubble. That is something that we looked at. Then we took a look at Earth as a rotating and a revolving object around the sun, where we observed that planet Earth that does rotate around the sun in a tilted axis in a kind of an elliptical orbit. We looked at the concept of aphelion and perihelion as well as apogee and perigee. Then we basically looked at the fact that how the tilt of Earth on its axis also results in the variation in terms of day and night, in the sense that we have different seasons that we experience, primarily owing to the tilt of the planet on its axis. Tilt of the planet on its axis means that on one position at one point on its orbit, it will appear as if the northern hemisphere is facing towards the sun and the southern hemisphere is facing away from the sun. So, for example, if this is the sun, at one position it will appear, let's say northern hemisphere being the top, that northern hemisphere is tilted towards the sun and the southern hemisphere is tilted away. That also means there will be a position on the orbit where the northern hemisphere appears to be tilted away and the southern hemisphere appears to be tilted towards the sun, which means that when you have these conditions, then whichever hemisphere is tilted towards the sun experiences the summer season and the other one experiences a winter season. So when we have winter in northern hemisphere, we have the conditions of summer in the southern hemisphere, and vice versa is also true. That also means that as the planet moves around the orbit of the sun, there will be positions, two positions in particular, when it is, let's say, in this position or in the other position, where the tilt is not in the same direction as the sun. So in that case, you will have the tilt, but neither the northern hemisphere is tilted towards nor it is tilted away from the sun. So in that case, both the hemispheres will receive equal amount of sunlight. And when you have both the hemispheres experiencing equal amount of sunlight, that is what is referred to as an equinox, where you have equal length of day and night. Then we basically looked on to the fact that what do we mean by latitudes and longitudes? These are imaginary circles. Latitudes were basically conceptualized in order to aid navigation, and they have been in presence for a very long period of time. These latitudes give us an idea about the position across the planet with reference to any other fixed place, for example. And equator being the largest or the longest latitude which is present, that demarcates 0-degree latitude. And then accordingly, based upon equator, we have the measurement 10 degree, 20 degree, 30 degree north, and similar in the southern hemisphere. Then we looked at the longitudes. Now, longitudes, basically, they were conceptualized to give an idea about timekeeping, the reference time. And there, the longitude or the meridian passing through the Royal Observatory in Greenwich, near London, that was chosen as the reference point or the prime meridian, which meant that the exact opposite of prime meridian, that is the 180-degree opposite of it, that is referred to as the anti-meridian. Now, these longitudes, basically, when we were talking about the longitudes, these have been conceptualized in order to give you an idea about the reference time. So what is the timekeeping in that sense? So that is where the longitudes were conceptualized and to give us an idea. For example, when we talk about the longitude which passes through Greenwich, that indicates the standard time. the international reference time, which is also referred to as the Greenwich Mean Time or GMT. Okay, so basically you will observe that the longitude, let's say passing through Greenwich, that is referred to as GMT, or that is observed at prime meridian. And that GMT indicates Greenwich Mean Time. Now here, these longitudes, they indicate the variation in time as experienced in different places. For example, and these longitudes are also chosen as the standard time zones being represented in these various countries. For example, when we talk about the Indian Standard Time, we take 82.5 degree east longitude to end up indicating the Indian Standard Time. And Indian Standard Time, basically, when we talk about it, Indian Standard Time is GMT plus 5.5 hours. So we are ahead of the GMT by 5.5 hours. Meaning what? Sun rises here significantly before than the sunrise is observed around London. So let's suppose in that condition, let's suppose if it is 6 a.m. in India right now, what will be the time in Greenwich, or what will be the international reference time in this case? If you think about, if it is 6 a.m. in India right now, what do you think will be the time observed in Greenwich? Very good, Chaitanya and Abhay, Pulkit also. So GMT would indicate 12:30 a.m. at night, right? 12:30 a.m. at night, and that is 5.5 hours behind the Indian Standard Time. So that is how you get an idea about what is the local time observed in different places. Okay, so here basically that is indicated by the longitudes all along the planet. Wherever you have these longitudes, they will indicate a kind of a reference time. If you can pay attention to this image for a couple of seconds here, you will observe the small markings indicating +1, +2, +3, +4, +5, indicating that these are an indication of the time zone with reference to the GMT. GMT being the prime meridian or the Greenwich Mean Time. This will indicate the GMT. Okay, so +5, +6, 7, 8, 9, 10, which means what? When we talk about +11 here on the eastern part of, let's say, Russia, now that is a region which will indicate, if it is +11 here, that means in this region the time will be GMT +11, means you have the sunrise almost 11 hours before what is observed in the case of London, right? And similarly, here you will find -1, -2, -3. That means here the sunrise and the day begins much later because planet rotates from west to east. So the sunrise happens here much later. Let's suppose we talk about the region of Alaska. Now, Alaska, this region that you consider, that indicates a time zone of around GMT -11, right? Which means the sun rises there almost 11 hours later than Greenwich. So here, this particular region on the eastern coast of Russia, there you have GMT +12. That means GMT +12. And here you have on the very close next to it, the Western Hemisphere indicating GMT -12. So that is GMT -12, which indicates what? Let's assume that right now it is 6 a.m. in India. In GMT or Greenwich, what is the time? It is, let's assume the time is 12:30 a.m. So that means in the eastern portion of Russia, where you observe plus 12, what will be the time in that region? Easternmost portion of Russia, that is GMT plus 12. What will be the time in that case? That will be very simple. That will be very good. It will be 12:30 p.m. here. 12:30 p.m. in the afternoon. Right, because this is GMT plus 12. GMT is 12:30 a.m. in the night, so this will be 12:30 p.m. in the afternoon. Now, what about this region, the region of Alaska? That is GMT minus 11, right? GMT minus 11, GMT minus 11. Which means what? If it is 12:30 a.m. at Greenwich, so there minus 11, it will be 1:30 p.m. afternoon. When? 1:30 p.m. in the afternoon of the previous day, that is 16th of May. Whereas the eastern part of Russia, which is experiencing 12:30 p.m., it is in the afternoon of 17th of May. So observe that the region of Alaska here, that is experiencing the afternoon of 16th of May yet. Whereas this region around Japan, that is experiencing 17th of May afternoon. So you have a difference of 1 day between these two. So how do you have that difference? So that is because as the planet rotates from west to east, that is why we say the sun rises in the east and sets in the west. So that is where, if you think about the planet, generally we tend to forget to imagine that the planet is basically a spherical object. So if you think about the planet, and this planet keeps on rotating from west to east, right? Let's suppose if this is the GMT, these regions experience sunlight earlier. Let's say this is the GMT. If here you have the sun, so these regions experience sunlight earlier. These regions will experience the day much later on. So eventually, each of these longitudes, they end up indicating a difference in time zone. Eventually, you will come to a situation where you need a difference between the date as well. So that is where a longitude is chosen that is exactly opposite to the Greenwich meridian, and that is the anti-meridian. That is 180 degrees. So that is chosen, that particular longitude is chosen very close to anti-meridian. That is chosen as the delineation or the difference between one day and the next. And this is referred to as the international date line. So when we talk about international date line, that basically represents the difference between one day and the next. Okay, always ideal will represent the difference between one day and the next day. So these regions, that is this portion that you look at it, these regions are your Western Hemisphere. Western Hemisphere. So here the sunrise happens later, much later. And here we have seen, for example, in the region of Alaska, what is the time? If let's say right now, okay, how many of us have not understood the, okay, before I proceed, let me make one thing very clear, okay? before I proceed, let me make one thing very clear. We have many students here. Many of them will be asking questions, right? Kindly have patience. Please don't become so impatient that if you have posted your question, immediately you expect me to respond to it. Otherwise, see, all of them will have the questions. If we keep on responding to all of them, that is why we have a very qualified subject matter expert. I will be taking up the questions in between. I will be taking up the questions in the end. But in the meanwhile, have patience if you have put up the questions. Please don't start putting up comments like you have not answered my question. What is this? My question is not answered. All the questions will be answered. Have patience. If you don't have patience, then don't have the expectation of the questions being answered as well. So please get that very clear and let me make myself very clear in that aspect. Okay? All of you. So here, basically, let me tell you the entire aspect of that time zone again. So here, when we talk about this, the time, so we get an idea of time, as I was telling you, with the aspect of the longitudes. Longitudes end up representing the idea of what is the time which is observed in different places. So when we talk about, let's say, the time zone, GMT is referred to as the point of reference. Point of reference in the sense that it is the standard time. And accordingly, around the globe, we've observed the kind of a time with respect to the GMT. So here, when we talk about the Indian Standard Time, the Indian Standard Time is the meridian passing through 82.5 degrees, which passes through the region of Uttar Pradesh, then you have Madhya Pradesh, Chhattisgarh, so on. It is that particular meridian which is taken as the Indian Standard Meridian. We will study about it in Indian geography again. So there, basically, when we talk about Indian Standard Time is represented as GMT plus 5.5 hours. Which means what? Which means Indian Standard Time, that is here, this one, which you have as the Indian Standard Time, that basically is 5.5 hours ahead of the Greenwich Meridian Time. So that is where you will observe +1, +2, +3, +4, +5, +6. So these represent number of hours which these places are ahead of the GMT. So here, if we take a look, let's say at the eastern portion here of Russia, that is indicating +12. So now let us think about it. If let's say in India right now it is 6 a.m. in the morning, that means it will be, and India is 5.5 hours ahead of GMT. So if it is 6 a.m. in the morning in India, what will be the time at Greenwich? Minus 5.5 hours, that is 12:30 a.m. in the night, right? 12:30 a.m. for which day? For 17th of May. Okay, 17th of May. So here, let's say, here we have 12:30 a.m. observed in Greenwich on 17th of May. Right? It is 6 a.m. in India. It is 12:30 a.m. in the morning in Greenwich. Now, here in the eastern part of Russia, that will indicate, let's suppose, GMT plus 12. So, GMT it is 12:30 a.m. So, what will be the time here? Plus 12 hours. So, 12:30 a.m. plus 12 hours. So, here GMT plus 12 will be how much? 12:30 p.m. Okay. Lakshmi, please be very attentive. Otherwise, you are the one who will start putting up the statements that my doubt is not clear, my questions are not responded to, etc. If it is 6 a.m. in the morning here, if you deduct 5.5 hours, please, I don't want to get into the portion of CSAT here. Okay, I don't want to get into the portion where I start talking about arithmetic with you guys. 6 a.m. in the morning, if you deduct 5.5 from 6, what is it that you get as a result? Is it 11:30 or is it 12:30? Let me know. Think about it. Is it 11:30 or 12:30? Why will it be 11:30? Guys, please understand, to if it is okay, that means you guys are very well placed for your CSAT. If it is 12:30 a.m. plus 5 hours, will be how much? It will be 5:30 a.m. plus 5.5 hours. What will it be? 5.5 hours will be 6 a.m. So if it is 6 a.m. in India, it will be 12:30 a.m. at Greenwich. Is that clear, or is that still not understood? Is that clear? Or anybody having any doubt in this? Good. Okay, what is not clear? Let me know. See, if your addition and subtraction is not in place, guys, please just add 5.5 or subtract 5.5. That is more than sufficient. Okay. Please don't spend so much time on this aspect only that geomorphology is not covered at all. Okay. It's very basic arithmetic, guys. Understand. Again, I will tell you guys, please understand, when you have 6 a.m. in morning in India, what will be the time at Greenwich? So, Indian Standard Time is GMT plus 5.5. So, GMT is equal to Indian Standard Time minus 5.5 hours. If it is 6 a.m. minus 5.5 hours, it will be how much? It will be 12:30 a.m. in the night. 12:30 a.m. for 17th of May. Okay. Now, this is the portion where the eastern portion of Russia, when we talk about, that is GMT plus 12. So, if it is 12:30 a.m., right? 12:30 a.m. I hope that we know about time, looking at the time, etc. 12:30 a.m. means in the night, right? So 12:30 a.m., if it is present at night in GMT here in this region, so here in Russia, they would have experienced the sunlight 12 hours before. So that will be GMT plus 12. That is around 12:30 p.m. at noon of 17th of May. Okay. And on the other side of the Greenwich Mean Time, that is on the region around North America and United States and so on, here you will observe what? You will observe that it is indicating -1, right? Excuse me. It is indicating -1, -2, -3, -4, -5, -6, and so on. So here, if you will observe, this is indicating -11. So if, let's suppose, I am measuring the time in Alaska. Alaska is GMT minus 11. GMT was how much? 12:30 a.m. at night. So minus 11 will be how much? Trust my arithmetic when I'm doing so. You can use your own time to do your calculation and arithmetic. Trust my arithmetic in this aspect. So Alaska will indicate 1:30 p.m. in the afternoon. But 1:30 p.m. in the afternoon for which date? for the previous day, that is 16th of May. So here you have Alaska experiencing 16th of May. Here you have Russia indicating 17th of May. So how do you delineate one day from other day? That is what is indicated, or that differentiation is done by the international date line. So international date line basically is representing the 180-degree longitude, that is the anti-meridian, which demarcates the difference from one day to the other, right? So these areas will experience the next day. And why is it so? Because sun rises in the east, sets in the west. So as the sun is rotating, the portions on the east of the GMT, they will experience the sunrise first. But when you cross the IDL, you have to adjust the time for that sake. Because if you cross the IDL from any portion to any portion, let's assume you are crossing the IDL from here. This is the IDL, right? Now, just to give you a direction, idea of the direction. So if this is north, this is considered as east, this is considered as west, and that is considered as south. So for the ideal, if you consider that the ideal, this will be the east of ideal, this will be the west of ideal, right? So what happens if we cross the ideal from east to west or west to east? So we have seen earlier, when we talk about the international date line, they will indicate the difference between one day and the next. So here, basically, why the ideal is zigzag, I will come to it. So let's suppose in the west, we are experiencing 17th of May. That is the portion of India, Japan, Russia, everywhere. Let's suppose we are experiencing 17th of May, and we have seen that the eastern portion is still experiencing 16th of May. 16th of May. So let's suppose you sit on a plane, you hop on a plane, and you move from here all the way to the east. That is somewhere, let's say around Hawaiian Islands and so on. So as you move from west to east, you are moving from a region where there is experiencing of 17th of May to a region where they are celebrating 16th of May. Let's suppose you have your birthday on 17th of May. Let's suppose. Now, once you cross from west to east, you go there and there it is still 16th of May. So there you will get to relive your birthday again. So in your life in general, you have gained a day. So when moving from west to east, right, you get to relive your birthday again. So here, gain a day in general, because you get to live that day again. So you tend to gain a day. But in your watches, in your various mobile phones, everywhere, calendars, where the date is indicated. So when you are in the western part of the IDL, the date indicated is 17th of May. Now, when you are coming to the new region, it has to indicate 16th of May. So what is the adjustment you have to do to your watches? Overall, you have gained one day in your life. But you need to adjust your watches as well when you cross the IDL, because the other region is experiencing different date. So in that case, you have to subtract a day in your watches and in your clocks, because the other region is still in the previous day. So here you subtract a day. Yes, very good. And then what happens when you move from east to west? When you move from east to west. So you are moving, let's say, from here to here. Now let's suppose you have your birthday on 16th of May. You reach to the region of Japan, there you find that people are already in the later part of 17th of May. So in your life, you have in a way lost a day, right? You won't get to live that day again. So you have lost a day in general because you have skipped a day as you have crossed the ideal here. So here, basically, you tend to lose a day. And what is the adjustment you have to do to your watches and clocks? In your watches and clocks, as you move from eastern part to the western part, you are moving from a region which is experiencing the previous day to a region which is experiencing the next day. So you have to add one day, right? You have to add a day. So that is the adjustment that you need to do while crossing the ideal, either from east to west or from west to east. Now, this ideal is not a straight line, as you will observe. This is zigzag. This lies along the region of 180-degree longitude, but it is not at all straight. It is significantly zigzag. Now, why do you think that is the case? The reason is very simple in that case. The reason is the fact that if, let's suppose, this would have been straight, let's assume that by some event of nature, this would have been a straight line. In that situation, it would have cut various different countries in half. So that means one part of a country is experiencing 16th of May and the other part of the country is experiencing 17th of May. That will never be good for that country, is it? That in the same country, if you are experiencing two different calendar dates at the same time, it is never good. So that is why, in order to avoid the sovereign borders of the countries, that is why ideal is not a straight line. Ideal overall, if you will observe, it is not straight but zigzag to avoid political and the country borders and to not cut some countries in half, so that overall each country experiences one day. Losing a day in east and add a day in west. Mona Lisa, don't learn by this like this. Learn, try to understand where you are moving, east to west, west to east. With that aspect, get an idea. Okay. And any doubts that we have up till now? Ananya, before that in eastern side there was Russia and now it is changed. See, east and west is not fixed. Can east and west be fixed ever? If you think about it, basically we can say that India is to the west of China, but India is also to the east of Pakistan. So can we say that India is always to the east or always to the west? Never. So with reference to ideal, here Russia is to the west and here US is to the east. If we have the reference, let's say at Greenwich or the GMT, then the reference point will be different. So that is how about the direction. Okay. Ashwant, if a person is traveling in flight while calculating time, leave the flight. Okay, in the flight, if you calculate time, that depending upon whether you are moving from Singapore to LA or moving from Singapore to London, that flight time you will calculate. Leave that flight, take a boat. Boat is easier. Take a boat from here, move from here to here, right? You will experience that loss or gain of time, isn't it? That boat will be very cheap also. Flight, you will have to get tickets, visa and all. Boat very easily available. Hop on a boat here, climb here, right? No adjustment of time required. So in that case, when you move from west to east, you will end up gaining a day. Is that understood? Okay. Why this ideal is present there only and why not anywhere else? That is what I have been repeating multiple times. This represents 180-degree longitude, 180-degree meridian. That is the region of anti-meridian. So that is where it represents, if you will observe, plus 12 minus 12 hours of differentiation, if you will observe in the time. So that is why anti-meridian, the exact opposite of the meridian, that is chosen. Okay. Why is Western Hemisphere marked as East? My dear friends, please understand, direction is never going to be fixed. Can we have the condition where every place will be always to the west? If, let's say, I say United States. Now, if I ask you with reference to Pacific Ocean, United States is to the east or to the west, what do you think will be the answer? Abhay, you had asked this question. If I ask you that United States is to the east of Pacific Ocean or to the west of Pacific Ocean, what do you think will be the answer? It is to the east of the Pacific Ocean, isn't it? So how come it is the Western Hemisphere and it is to the east of something? So it is the reference point. Here the reference point is the international date line. Okay? Is that understood? Amit, then why they are called Western countries and not Eastern? You can start calling them Eastern countries, my dear friend. There is no discrimination in that. You can start your own nomenclature. But as we talked about it earlier, the region of the prime meridian, if you take the reference point from that perspective, prime meridian tends to divide the entire planet into two hemispheres. One is the eastern and the other is the western hemisphere. That is why they are referred to as the western countries. But if, let's say, I have to measure the, okay, I will do something easier. Generally, unless and until we talk about India, people don't get that clarity in mind. Suppose I consider India. India is generally considered in the eastern hemisphere. I hope nobody has doubt in that, right? Amit, you had the question. I hope we all are aware that India is in the eastern hemisphere. India. Here is Japan. Now, with reference to Japan, is India in east or is India in the west? With reference to Japan, it is in the west. So do we start calling India a western country now because it is to the west of Japan? We cannot do so, can we? So it is a kind of a reference from where you are taking that direction. Okay, that is why the reference point is taken in that case. Okay. Now, after this, I think we should move ahead. The rest of the doubts the SMEs are here to address. Now, here, as we move ahead, basically, we come to the systems of the Earth. So, overall, the planet has got 5 different systems associated with it. You have the hydrosphere, consisting of all the water bodies which are present on the planet. You have the biosphere, or rather, the lithosphere, the ground that we stand upon, the land that we stand upon, that is the lithosphere. You have the atmosphere, the air which surrounds the planet Earth, that is referred to as the atmosphere. The cryosphere represents all the frozen regions, the ice capped regions, the high altitude ice caps, as well as the polar ice cap. So that is the cryosphere. And then you have the biosphere representing all the living beings on the planet. So this biosphere is generally an outcome of the interactions of all the other ones that indicates the living species and their influence across the planet. So here we shall be studying the hydrosphere, lithosphere, atmosphere, and parts of cryosphere in general. And this biosphere, that is something that you study in the portion of environment and ecology. Okay, environment and ecology. Now here in lithosphere, this is what we will be studying in the portion of geomorphology. That is basically what we are going to address in the portion that we will begin. So here basically just a basic brief about geomorphology, a kind of an introduction about the different landforms. So when we talk about the different landforms in general, you come across the aspect of hills, mountains, plateaus, etc. So just to introduce you to them, that what they are, what do we understand when we talk about hills, what do we understand when we talk about the mountains, just to give you an idea, here this is what is indicated by a mountain. So in the case of a mountain, this is actually the image of Mount Everest here. So when we talk about a mountain, you will observe a kind of a very conical peak. So it has significant height, right? Conical peak, steep slopes. That is a characteristic that you can always associate with a mountain. Now, in the case of the mountains, many of the times they have such a great height that everything exists in frozen form. Nothing exists in liquid form, that is the gaseous or the water vapor in general, or water in general cannot exist in liquid form at that great height. So it freezes into ice and snow. Now that ice and snow, under the influence of gravity, it starts flowing down the slopes ever so slowly. And that movement down the slopes that you observe of all the ice and snow, this movement down the slope of ice and snow at a very slow pace that you will observe, these are what are referred to as glaciers. These are what are referred to as glaciers. These are very slow moving mass of ice. Very slow moving mass of ice. Why do they move? Move under the influence of gravity. Okay? And it is these glaciers and these ice masses, when they come to a kind of a height, or when they come to the base of the mountains, that is when they start to melt, and that is when they feed the various river systems that we have. So that is basically observed in the case of the glacier. Any of the mountain peak that you consider, especially in the Himalayan region, majority of them will have some or the other glaciers originating from them. And majority of the Himalayan rivers also that you will observe, they are fed by these glaciers and the melting of this snow. So this is observed in very high altitude regions and also in the polar areas. In the polar areas also you experience this. Then you have how the glaciers move under the influence of gravity. Okay, think about it. It is very simple, guys. Understand this. Suppose this is the mountain. If I have a lot of ice here, what will be the tendency of the ice? Will that ice tendency of the ice will be to come down, or will ice try to climb up the summit and hoist its own flag? What do you think? The tendency of the ice will be to come down. But why will the ice come down? If there is no gravity, will the ice ever come down? No. So that is why it is the influence of gravity. When you stand on an inclined plane and let's suppose you fall down and you slip, now that is the influence of gravity happening, right? It is your own mental ability which is leading to that fall, but eventually it is due to gravity that you are moving down rather than rolling up. So that is why here also, basically you will observe that there is a movement down, that is glacier. Okay? Flowing snow is never referred to as a glacier, Kishan. Snow never flows. When we talk about the glaciers, these are very hard, and see, I have written moving mass of ice. There's a difference between difference between ice and snow. Snow is basically deposited on top of a region, and that is very light in general. That snow, after repeated deposits, eventually becomes very thick, very dense, and that is what we refer to as the moving mass of ice. I will show you the images of the glaciers as well. I will show you the images of the one of the most dangerous glaciers which the mountaineers go through while climbing to the Everest, that is the Khumbu Icefall. All the images I will show to you, but when we get to the relevant portion. Okay. Lakshmi, due to mass of glaciers, yes, that is correct. And right, Ashwant, glaciers are included in cryosphere? Absolutely, yes. Frozen compact ice is not called glacier. It is the movement of the ice which is referred to as the glacier. Now here, then we come across a hill. Now, what is a hill? Hills are in general different from the mountains. The image also will indicate to you. Again, take a look at the mountain. Here, this is the mountain. Observe the features of the sharp slope that they have, steeper slope, conical peak that they have. Hills, basically, you will have a rounded peak, a very rounded peak in the case of the hills. So height is less, rounded, lack of a peak, rounded top, and gentle slope. That is a kind of a hill. For example, Aravalis right now in the region of Rajasthan that you observe, these Aravalis have been reduced to a hill, right? Now, here, then we come across what is referred to as a plateau. Plateau is referred to as a flat tableland-like surface. So plateau, generally you will observe that the slopes are very steep, but the top is flattened. So here this is a plateau, generally formed due to volcanic eruptions and the activities of volcanoes, here creating that flattened top and a steep side. So that is a plateau. For example, you have the Deccan Plateau, the entire Peninsular Plateau, Chota Nagpur Plateau. These are basically made up of very hard rocks. Observe here, a flat tableland-like structure, right? So that is basically a plateau. So these are basically the initial stages. All of that we will come across while we study the portion of geomorphology. Can mountains become hills due to erosion? Vetri? Absolutely yes. Absolutely yes. When we talk about the Aravalis at one point of time, they were considered to be very tall mountains. You had multiple glaciers originating from them. But now today, look at the Aravalis. You can basically climb it in half a day and still be back for tea and snacks in the evening. So they have been reduced to a hill because there are external forces acting, erosional forces acting, which end up removing them. Okay. Now, a question which was framed from this particular area in the exam. On 21st of June, what is the condition here? 21st of June, sun does not set below the horizon at the Arctic Circle. Sun does not set below the horizon at Antarctic Circle. Shines vertically overhead at noon at equator, shines vertically overhead at the Tropic of Capricorn. I hope we understand the meaning of horizon. Horizon is the region where you observe the sunset and the sunrise. That is the imaginary place that you see where it appears that the sky meets the land. That is referred to as a horizon. Good. Majority of you have given the correct answer in this. So on 21st of June, the sun does not set below the horizon at the Arctic Circle. What do we mean by that? So basically, when we talk about 21st of June, here, if let's say this is the planet and here this is the sun. So 21st of June, which will be tilted towards the sun, northern hemisphere or the southern hemisphere? What do we think? Which is tilted towards the sun on 21st of June? Northern hemisphere will be tilted. So here, let's suppose we draw the axis. Let's suppose we draw the axis. Let's suppose we draw the equator as well. This is the Arctic Circle. Let's suppose we draw the circle of illumination. This will be your circle of illumination. So here what will you observe? In the region of the Arctic Circle, here you will have permanent day. Permanent day. That means no sunset. That means sun doesn't set below the horizon in this region. So sun does not set below the horizon at the Arctic Circle. That will be the correct answer on 21st of June. Does not set below the horizon at Antarctic Circle. When will this be observed? This will be observed in the winters of northern hemisphere and summers of southern hemisphere. So this will be 22nd December. Very good. Beautiful. The winter solstice shines vertically overhead at noon at equator. When this will be experienced? This will be the portion of equinox. Okay, how many of us we don't understand the meaning of horizon? I gather significant proportion of us, we are getting confused by horizon, the word horizon. That what is this setting below the horizon? Okay, right. So when you think about horizon, it is an English terminology. It is not a geographical term, first of all. So basically, when you take a look outside in the sky, you would observe the sunrise and the sunset, right? So horizon is the place where it appears that the sky meets the land, right? When you take a look at the sky, eventually when you take a look at the horizontal portion, eventually it will appear that the sky meets the land. And that is where you experience the sun to rise and sun to set, right? So for example, if this is a kind of a landscape, and the sun starts rising from here and starts moving upwards into the sky, this will be the horizon. So horizon is that place where you experience the sunrise and the sunset. Is that understood now? Or anybody of us who have no idea about what is horizon? Understood? Okay. Sun does not set below the horizon means that is sunset. Sun does not rise above the horizon means there is no sunrise. Okay, when we say horizon, that is where the sky meets the. So right now itself after the session, step outside your house and look into the sky. Eventually, where is it that you will feel that the sky is meeting the land? That portion will be referred to as the horizon. So what happens when the sun rises? It appears as if the sun rises above the horizon. It has emerged from somewhere and is now shining upon us. And during sunset, it will simply again go down. We say that the sun has set below the horizon. Okay, below the Arctic Circle means here we don't have below the Arctic Circle, we have below the horizon at the Arctic Circle. So at the Arctic Circle we don't experience sunset. This in very simple terms indicates that no sunset in Arctic Circle. Arctic Circle. Here No sunset in Antarctic Circle. Here, this means that you have equal length or directly the position of the sun is above equator. Position above equator. Okay. So below and above the horizon is no. Okay. I will ask this question again. How many of us we have no idea about what is horizon? So if you have an idea about horizon, mark A. If you have no idea about horizon, mark B, that is no. Okay. If you have idea about horizon, mark A, otherwise mark B. I have launched a poll, guys. Okay. So we still have a good number of people who have no clue what is horizon. Listen to this carefully, guys. When we say a horizon, what does that mean? So when you take a look outside your building or outside your building into the sky, you will observe that in the horizontality, you have other buildings, etc., which are present, maybe the trees, etc., which are also present. But when the sun is rising, isn't it that you will observe initially the sun to appear like this? Slowly you have a greater amount of sun which appears, slowly and steadily that increases and that comes up, right? We experience something like that, and then the sun climbs up the sky, right? We experience something like that. So that is rising above the horizon. Now here, during the time of sunset, what do you observe? Regardless of whichever part of the world or whichever part of the country you are in, during sunset, what do you observe? You observe that initially the sun is here, it starts moving down, it starts moving down. Eventually, what will happen? This sun overall will start to set. It will be in this position, then slowly and steadily it will move down. Slowly and steadily, if it will further move down, and eventually after that, it will completely set. So that is why at the time of sunset, it is referred that the sun is moving down the horizon. Okay. Is that understood or is that not understood yet? Okay. This is basically the English vocabulary that we are struggling with. This is not a geographical concept. So all of you who are struggling with the portion of horizon, kindly open up the dictionary, kindly take a look at the meaning of that word. What is it that you have not understood? Kindly let me know. It is not the simple aspect that I have not understood this. So repeat the entire thing. Let me know. Horizon is the place where the sky appears to meet the land. That is what is horizon. And we have seen earlier, sky doesn't, okay, I was afraid of this. So now that I have seen the sky meets the land, so now I have a question, where does the sky meet the land? Okay, please understand. When you look up into the sky, when you step outside your house, I am sure that you are old enough in your life to have looked up at the sky at least once in your life. So when you take a look into the sky, basically you will observe that the sky is a bit of a curvilinear figure, right? Sky is not flat. It is not as if you see the sky to be flat, earth to be flat, and in between you can look at the windows nearby. No, sky appears to be a bit curvilinear. So there will be an appearance almost in the horizontality that the sky is appearing to meet the land. So that means when the sun is rising in the east, it will appear that it is rising up here and then setting up in the west, right? So today do one thing, today evening, observe that sunset or observe the sunrise tomorrow morning. Where do you think the sun comes from? Do you think that some suddenly sun appears in the afternoon and then suddenly it disappears? Do you think that happens? No. Sun rises in the east, sets in the west. So when it rises up, it appears as if it is coming up the horizon, isn't it? Deepika, I agree. But if we are having difficulty in understanding, let's say, the arithmetics of 6 hours minus 5.5 hours is how much? And if we have problem imagining the movement of the sun, then this is the best pace that we can go for. Okay. Is that understood? Okay. Sun is going up in the sky. Is it called horizon? No. Sun going up in the sky, why will it be called a horizon? Horizon is that particular. Okay. Do one thing, guys. When you think about the horizon here, basically whenever you talk about the horizon, it is that place where the so okay, you can understand it in another aspect. When you take a look up at the sky, sun rises up, sets down, right? But the point it rises up, that is referred to as the horizon. So sun rises up in the sky beyond the horizon. So understand what the question tells you. Rather than panicking into this, understand what the question is telling. On 21st of June, sun does not set below the horizon at Arctic Circle, means there is no sunset in that region. Sun does not set below the horizon at Antarctic Circle means there is no sunset in that region. Setting below the horizon means that there is a sunset. Horizon indicates a sunrise and a sunset, isn't it? So that is basically the aspect which is being talked about here. That is where you have to understand that at what position, in which part of the year, what is the condition of sunrise and sunset that we experience. Here, this is observed at equinox. This is observed in December. This is observed in June. Look at yesterday's annotations of the PPT. You will get a clearer understanding. Fourth option, shines vertically overhead at Tropic of Cancer. This is observed in December solstice. That is when we observe that. Okay. Now we come to the portion of basically the earth, its interior, rocks and plate movements. So here basically understand, this is where the main portion of geography will start. Whatever doubts, the aspects that we were having till now, please understand that is not the main portion of geography. That is the basic introduction. So that gives you an idea about what lies ahead. Okay, so all of us who were fidgeting with and fiddling with the term horizon, and we are fiddling with what is GMT plus 5.5, GMT minus 5.5. Now we will start the portion of geography. Till now we were doing the basic intro. So this is a portion which is particularly relevant both for your prelims as well as for your mains examination. So here, what is relevant for your prelims here, basically in the prelims, we are going to look into the, or what is asked is the structure of Earth, then basics of rocks, then plate tectonics. It is from these areas that the questions are generally asked in the prelims. And in the mains examination, you get questions from the various theories that we will study here. So in 2022, you had a direct question in the mains coming from the rocks itself. So that will also be included here. Rocks, the types of rocks that we have, continental drift theory, Okay, seafloor spreading theory. And then the plate tectonic theory. So these are the portions where you get frequent questions which are asked. Frequently, UPSC tends to repeat the questions from this area, and that is frequently asked in the examination as well. So here we will initiate the discussion. First of all, we will initiate the discussion from the very basics of the formation of the planet Earth itself, that how is it that the planet Earth got created, and that will help us understand the aspect of internal structures as well, that what is the internal structuring of it. Now here I would want to tell you something, I would want to recommend you something. Please understand that if, let's say, the basics are understood in an easier manner, it will always be possible to elevate the level of concepts, to elevate the level of discussion. That is why what I would like to recommend to you is do the basic homework, do the basic preliminary studies of these portions, then you will be able to understand these basics in a much better way, and then we can elevate the level of discussion. Otherwise, we shall be very much restricted to the basic portion itself, where you will also be very happy that, okay, we are talking about latitude, longitude only. I will also be very happy because we are dealing only with the very small portions, but it will not help us significantly to gain an advantage over the others. So if we want to gain a lasting advantage, I would request all of us to do the basic homework so that we can elevate the level of discussion a bit. Okay? So we start with the basic aspect of the formation of the planet. Now, the formation of Earth in general, that started roughly around 4.5 billion years ago. Okay, so this began roughly around 4.5 billion years ago. And this happened by the method of accretion. So for the formation, you have the method of accretion which was used. What is method of accretion? A kind of an accumulation when things get together. So method of accretion. So here what happened? How is it that the planet got created? So understand, when the sun was formed and the solar system was initially formed, at that point of time, you had the presence of the sun, and all around the sun, you had the presence of lot of dust particles. You had the dust particles which were moving around. And they were moving around. Why? Aided by the gravitational pull of attraction of the sun. The sun was pulling them, right? And these were consistently moving around all around the solar system. You had a lot of debris, lot of small and large dust particles which were consistently moving around the sun. No fixed orbit, no particular fixed path. They were just randomly moving around. Now, when you have many of these dust particles which are randomly moving around, means what? They will get in the path of each other, right? They will get in the path of each other, and there is a chance of collision happening as well. So they will be in the path of each other. They will start to collide, isn't it? Now, when collision happens, there are a few things which can happen. Let's suppose two objects, when they collide, the force can be significant, and they can then disintegrate and broken into small parts and be thrown away. But if, let's say, an object is moving in this direction, other object comes and then collides. So what will happen? It will get a push. And whenever two objects will collide, there is always heat which is produced. Whenever two objects will collide, always significant heat is produced. If you don't believe me, ask someone to slap you on the face, then touch your cheeks. You will always feel that the temperature is higher. But please don't replicate it on someone. You don't slap someone. Because if you want to understand how heat is produced, Go to your parents, ask anyone or your friends. I think your friends will be more than happy to oblige. So ask them to hit you a tight slap. Observe that the cheeks will get hotter. So collision produces heat, lot of heat. At the same time, when two objects they are colliding, that heat produced sometimes is so significant that the two objects can get welded together, right? Due to high amount of heat, the two objects can get welded together. So suppose earlier you had two of the objects moving separately, but after collision heat is produced, now this has become a larger object. Now this larger object will be moving with a greater velocity. Now also one thing we have to keep in mind, that each and every object has got its own gravitational pull of attraction. Every object has got its own gravitational pull of attraction. Larger the mass, greater is the gravitational pull. Okay, I hope, okay, I will write it down. So, larger the mass of the object, greater is the pull of gravitation. Larger the mass of the object, greater is the pull of gravitation. So, like this, you had multiple small collisions which were happening around the dust particles. These dust particles were colliding, becoming large enough, and then once they started becoming large enough, they had gravitational pull of attraction that they could attract smaller other dust particles. Now, what that led to was a situation where, if this is the sun, let's suppose, around the sun, now you had large chunks rather than dust particles, you had large chunks which were moving around the sun. Very large chunks which were consistently moving around the sun in different paths. Now, these also carried out the same thing. So, if you have one large chunk, other large chunk simply comes, it hits. The heat is so much, it gets welded to this. But due to the force, there is a spin. There is a kind of a spin which is induced. And that is where the combined material would start spinning. Then let's say there is another collision. It will further reintroduce that spin. So like that, consistently these objects were being pulled by the gravitational pull of attraction by the sun. Slowly and steadily, heat was being produced due to enough amount of collisions every day. Almost millions, billions, trillions of collisions were happening. So you can imagine the heat produced. Eventually, multiple of these larger objects, they collided to form planets. And that is when planet Earth was created. But when planet Earth was created, it was hot molten ball of mass, nothing else. It was significantly a hot molten ball of mass which would be consistently moving around the sun. Molten Earth, which would be consistently moving around the sun itself. Right? Now, this planet Earth was created as a result of many different objects which were existent. Many of them, they collided to produce this planet. So, it had many different types of elements. It did not have only one kind of element because many of the objects were involved. Now, if ever you have tried the experiment, let's suppose where you have, let's say, a utensil, a glass beaker, anything that you can consider. Now in this, if I pour water, right? Let's suppose I pour water, I pour honey, and then I pour, let's say, oil. Okay, so I pour water, honey, oil, let's suppose. Now in that case, what will happen? Will all of them mix together perfectly well? Or do you think they will create a kind of a difference in terms of arrangement of structure? It will create a different density. So oil will float at top, honey will sink at the bottom, water will be present in between, isn't it? So depending upon the density, the materials arrange themselves. The heaviest of the materials, they sink to the bottom. The lightest of the materials, they will come to the top, isn't it? So here also, in the case of the molten earth, heaviest materials settle down. Heaviest materials settle to the bottom. Now at this stage, the heaviest material which was present was iron and nickel. These were the heaviest materials which were present. So when we have, let's suppose, the molten planet, now the heaviest of the materials will settle at the bottom. And by the way, the bottom is not this. Okay, this is not the bottom. Bottom is the center. This is considered to be the bottom. So that is where the heaviest materials, they will settle down. So since that time onwards till today, the bottom of the planet Earth is constituted chiefly by iron and nickel. And this has formed the core of the Earth. That is iron and nickel. That has formed the core of planet Earth. Now, in fact, are we comfortable up till this region? If yes, then we will elevate it. Okay. Good. So now let's elevate it a bit. So basically, this is how you had the molten planet Earth getting created. But how is it that the moon came into existence? Moon, basically, it is only after the various Apollo missions and the Apollo landings where we could get the evidence of the rock samples in the moon that we get an idea about the formation of the moon. So, just to tell you the brief basics, in the initial stages of the solar system, you had these millions and billions of these collisions happening. Now you don't observe these collisions, do you? You don't. Now you observe a very stable solar system because all those objects, they have been consumed due to collisions. Either they have broken or they have assimilated themselves into larger planets. So that is why now you will not observe any of these objects moving around the solar system other than the asteroid belt, other than few comets here and there. You don't get that huge proportion of objects moving around. So here, when the solar system was young, at that point of time, you had a lot of objects which would move around the solar system, which would move around the planetary orbits with great speed. So it is said that at this time when the planet was getting formed, that is, the hot molten part of the planet was getting created, at that point of time you had a very giant object almost to the size of Mars, and that was referred to as Theia. You had Theia. giant Mars-sized object. And this Theia actually collided with Earth. But the Earth was completely in a molten state. It was not fluidic like water that it will immediately collapse like in the cartoon movies. But you had a kind of a dense liquid form, if you can imagine. This Theia, when it collided, what it did was some of that portion of Theia that was assimilated in the planet, but significant portion of the molten materials, they were ejected from the surface of the planet. Now, by this time, the size of the Earth was significantly very close to what we have today. So here, the Earth had started exhibiting its gravitational force of attraction. So all these molten materials which were expelled from the surface, which were thrown due to the impact of Theia, they were trapped and caught by the Earth's gravitational pull of attraction. They were not allowed to escape into the outer space. So all those objects, they got together in the molten state itself. And then they started cooling down and they were held by the Earth's gravitational pull of attraction. And that is when we had the creation of moon. So you had impact, collision with the planet, with Earth, molten materials thrown outwards, thrown outwards, these molten materials were trapped by the gravity of Earth, and these molten materials, they have solidified, but they continue to move across the planet even today, and that is what we have as the moon, formation of moon. Okay, so here, when the impact or the collision with Theia happened, at that point of time, significant amount of materials in the region, they were basically mixed, appended. And that is how you had the formation. This is the moon. But still, everything was in a molten state. Now, there was a lot of heat. The temperature was very, very high. But then, slowly and steadily, the phase of cooling began. Now, if ever you have, let's say, boiled a utensil full of milk, let's suppose, if ever. Now, when you close it down, when you close the gas stove down, after some point of time, you will observe a development of a thin layer on top of that milk. If you touch it, it appears to be cooler. But if you dip your fingers into the milk, the bottom region is very, very hot, isn't it? So what does that tell you? Cooling begins from the outside, always. In this case also, when we talk about the planet, from the time that it was created in a molten state around 4.5 billion years ago to the present date, planet has cooled down at a tremendous pace. And that is what we have as the blue planet. But how? So basically, again, the cooling was initiated from the outside. Now, when the cooling was initiated from the outside, here, the inner portion was still very hot. But the outer portion, as it is cooling down, as the outer portion is cooling down, it will develop some wrinkles, it will develop some creases here and there, isn't it? Whenever you have a hotter fluid, and take the example of milk itself, when the layer of fat on top, when it begins to cool down, what happens? It will not be very smooth. It develops a kind of a wrinkle. So that is where cooling began from the outside. So you had a phase of cooling. Phase of cooling, where the cooling was initiated from the outside. Initiated from outside. Now, what did it mean? Basically, from the outside, you had development of cracks, crevices, heights, depths, all of them were starting to appear. But the surface was nowhere as hard as what you find it today. The surface was still very, very soft, so it could easily be ruptured. Now, then comes the next phase. So here, in this phase, what is it that we observe? Surface is cooling, and you have very hot interior. Very hot interior, very high temperature. So in that case, when we have the interior regions which are in molten state, you had the molten materials and a lot of gases trapped in the interior as well. Now here you might wonder that we have the molten planet, how come gases are present in the interior? Gases should be present on the outside. But think about it. When we talk about gases, any compound, let's say an oxygen compound, let's say silica. Silica is what? SiO2. Alumina is what? Al2O3. Significantly rich in terms of the component and constitution of the planet. Then you have iron oxide, Fe2O3. All these compounds ideally are solids, isn't it? All these compounds are solids. But if you melt them down, what happens? While the silica, aluminium, as well as iron, they will be converted into liquids, this oxygen will get converted into gas, right? So that is where you had a lot of gas which was trapped in the interior. So molten materials plus gases trapped in inside the surface. Okay? Now gases were trapped inside the surface. Now these gases, they needed to come out. The gases will be required to come out. Whenever you have the presence of a gas, gas is lighter, so gas tends to come up, isn't it? So basically, all the presence of these gases, they started coming out. They wanted to come out. So here, that brought about a phase of degasification. Degasification means expulsion of gases from the inside. Expulsion of gases from inside. So that meant across the planet, you had these gases along with the molten materials, they started coming out. And they started coming out in the form of the series of hundreds and millions of volcanic eruptions, which would happen every day. On a daily basis across the planet, you had millions of these volcanic eruptions which would happen. Right? Millions of these eruptions. So all of them would produce so much amount of gases that all these gases basically that started modifying the early atmosphere of the planet. The atmosphere of the planet at the earlier stage was very different from the atmosphere that we have today. We'll study that in the evolution of atmosphere. It is at this stage where oxygen was also released, and oxygen and hydrogen they combined, and that formed water vapor. So that is when you had the formation of clouds. Water vapor was released. And that led to the formation of clouds, very dense cloud layers. Right? So dense cloud formation, dense cloud formation due to release of water vapor. O2, which combined with hydrogen to form water vapor. So you had the formation of very dense clouds. Now all these dense clouds basically they managed to block the sun. For a significant duration, they managed to block the sun. And when the sunlight was blocked, that meant what? Another significant rate of cooling. If you block the sunlight, significant amount of cooling is observed. So the surface started cooling down a bit more. And as it lost the temperature, eventually these clouds, they brought in rainfall. All these clouds, they continue to bring rainfall. And that leads us to the decisive phase, that is phase of torrential rain. Phase of torrential rain. Torrential means continuous. I will do one thing, I will not risk it out. So, continuous and heavy rain. Otherwise, I'll be flooded with the questions. That first you are saying horizon and now you are using torrential. Is it an English class or a geography class? So basically, continuous and heavy rainfall. So in this phase, all the clouds which were created, they continued to bring rainfall, continuous rainfall. It is estimated that it rained continuously for close to around 8,000 to 10,000 years. It rained continuously. Imagine if it had started raining around, let's say, much before the Indus Valley civilization, and that continuous rain would have happened even till today. That kind of rainfall spanning across many thousands of years. If we have 2 days of continuous rainfall, our cities get flooded. Imagine what thousands of years of rainfall would do. It is this phase which created the oceans. So you had continuous rains for almost 8,000 to 10,000 years. So this filled up the oceans and created the blue planet that we call home. That created the blue planet. So basically, that is how eventually the entire blue planet was created. So even today, Now, even during this phase of continuous rainfall, you had a situation where the materials, they started cooling down from top. So that is why the top surface started becoming colder and colder, whereas the bottom region, that continues to remain hot. Even today, the bottom portion of the planet is significantly very, very hot. And that is that heat which is still trapped in the bottom, that is what is referred to as the residual heat. Heat trapped in the bottom. That is what is referred to as residual heat. It is this residual heat, as we read the portions of geomorphology, we'll come across the fact that how this residual heat is still responsible for the earthquakes, the volcanoes, the land movements, the mountain formation that we come across. All of that is driven by this residual heat. Okay, so a very quick recap of the entire process, just so that some amount of it is retained in your minds. So very initially, if you talk about it, basically you had a stage. And by the way, this is an explanation. Please pay attention. You will not find it in the books. You will not find it in the reference materials. So kindly pay attention here. Okay. So initially you had when the solar system was just being established. At that point of time, the solar system was not as stable as you find it today. You had a lot of small objects flying around the sun here and there. Now, these objects would obviously get into the path of each other. And when these dust particles, they would get into the path of each other, they would undergo collisions. They would collide. And when they would collide, now collisions can happen in different ways. They can collide, they can disintegrate, move away from each other. They can collide, separate, and never come together. There can be a collision where they can collide and combine or join together because of the heat produced. So that kind of collision happened. Slowly and steadily, the mass of the materials undergoing collision, that started increasing. As it started increasing, its mass started to increase. Means what? The gravitational pull extended by that mass, that also started increasing. It started attracting more materials. It started getting more materials coalesced and attracted together. So after a few million years, you had a situation where rather than multiple of these dust particles, you had larger objects moving around the sun, very large objects moving around the sun. But they were not to the size of the planets. They were referred to as the building blocks of the planets. Now these would move significantly around the sun. Now, these also got together, right? So here, these also started getting together, all of them. Now, when they started colliding, again, heat would be produced, significant amount. Eventually, multiple of these objects, when they collided, that led to the formation of the molten form of planet Earth. Now, because the collision was happening between various different types of objects, so the Earth which was created was also a planet of multiple different elements, but it was in molten state. And that would mean that the heaviest materials would sink to the bottom. Whenever you have multiple different liquids mixed together, the heaviest elements will always sink to the bottom. So that is where, in the initial stage itself, the heaviest elements, they settle to the bottom. And they settle to the bottom. So which were the heaviest elements at that point of time? The heaviest elements were iron and nickel. This iron and nickel, that settled at the bottom and is still present in the bottom, and that forms the core of the planet. Now then, at that point of time, when everything was still very much molten, you had another large of these objects. You had multiple of these objects moving around the sun at that point of time. So another that large an object, which was the size of Mars almost, that was named as Theia, that collided with the planet Earth. And when it collided with the planet Earth, significant chunk of the surface was expelled from the planet Earth because everything was molten. But those portions which were expelled from the surface, they could not escape the Earth's gravitational pull. They were held by the Earth's gravitational pull. And they continued to be moving around the Earth due to the gravitational pull of attraction. They do it till today. And that is what we refer to as the moon. So this process of formation of moon, this has been asked by UPSC earlier. So this is what is referred to as giant impact hypothesis. Impact hypothesis. This is for formation of moon. Okay? How moon gets created, how moon gets formed. What happened to Theia after that? Significant portion was assimilated with the Earth's surface. Some portion was separated. Some portion, very minute portions, they even escaped. Now the planet was in a molten state, but it was hot from the inside. From the outside, it started cooling down. Now from the outside, when it started cooling down, it started wrinkling. It started developing creases. So that is when you had various depressed areas, basins, ridges, all these features, they started getting created. But the surface was still very soft in the sense that it was newly solidified. It could be easily punctured, but it was getting solidified nonetheless. Meanwhile, the interior, which was still very bubbling hot, the interior consisted of various different types of gases, as well as a lot of molten materials. Now, these gases, they started bringing the molten materials as they tried to rise up above the surface. And that brought about volcanic eruptions. You had a good phase of many millions of years where you had nothing but volcanic eruptions. Millions of years. Imagine. So imagine that, let's suppose, for 10 million years, 20 million years, there is nothing but volcanic eruption happening across the planet. So you had so many volcanic eruptions. And during those volcanic eruptions, the gases which were trapped in the interior, they started escaping and they started forming the clouds, the dense clouds. Now, these dense clouds, they started blocking the sunlight, further accelerating the rate of cooling. And when that rate of cooling happened, basically, again, the surface started solidifying much more. Now, meanwhile, all these clouds that were formed, they were so very dense that it continued to cause rainfall. Meanwhile, more clouds were getting created. You had a phase of torrential rainfall, a torrent of rainfall. Torrential rainfall which continued for almost 8,000 to 10,000 years. And that cooled down the surface quite significantly, not only the surface, the region underneath that as well. So that is how you had the creation of the oceans, and life germinated underneath the oceans. I hope we are aware that life did not originate on the land at that point of time. You did not have a landmass. You only had the entire of the planet covered under water. Land started getting created much later. So that is how life germinated in a single-celled bacterium inside the oceans. And that is what led to the formation of the blue planet that we call as our home. Still today, the interior portion is very, very hot. Still today, the interior portion has got a lot of molten materials present. And that heat which is trapped in the interior since the time of the formation of the planet itself, that is what is regarded as the residual heat of planet Earth. Okay? So that is about the formation of the planet Earth. I hope that this is something which is understood. This is generally not to be found in the books. So that is why it is very imperative for you to have a clue about it, to understand about it. Okay? Pulkit, but how Theia can directly collide rather than being trapped to revolve around. So if the mass is large enough, it can collide. It can have. So asteroids also, when they collide, rather than revolving around the planet, they directly come and have an impact. So when you have a large mass, it has a direct collision. About the formation of the sun. So formation of sun, you will study separately in science and tech. So sun was created due to the presence of the hydrogen atoms. These hydrogen atoms, basically, they get together to carry out the nuclear fusion. And that is when helium is produced. So a repeated chain reaction of this has led to the formation of not only the sun, but the other stars as well. Okay? Accretion means getting together, something which gets together. That is accretion. Then when we talk about residual heat, nearby residual means what? Something which is left behind. So this is the heat which has been left behind, which has been trapped in the interior since the time of the formation of the planet. Okay? Water vapor was formed as a result of expulsion of oxygen. Hydrogen was present in the atmosphere at that point of time. So that combined with hydrogen to form the water vapor. Okay. Do we have geoid shape because of the collision? Some part of it, yes. But slowly and steadily, as the planet started rotating, materials started to accumulate around the equator. That is where you had a slight bulge, and that is why you had the geoid shape. Okay. Is it the collision again which induced the rotation of the moon as well? So it is the collision of Theia which brought into existence the moon. And when you had objects moving away from the planet, they automatically have a velocity. So with that velocity, when trapped with the gravitational pull of attraction of the Earth, it continues to move around the Earth. Okay. If a question is asked about formation of the Earth, can we write these phases? Absolutely yes. Why won't you write these phases? This is not a kind of a fictional story. It has been told like a story, but it is very much the aspect of a reality. When one object will hit another, will they not break? Depends upon the type of collision. As I told you, you have the aspect of multiple types of collision. If you have read it in science, you would be aware of it. Or let's suppose we have not read it. If two objects, they face each other, they collide. If the speed is significant, they will break, they will throw away, they will be thrown away. But if an object is moving in this direction, the other object is moving with a faster velocity, and then there is a collision, then they will get together. Okay? Volcanoes happen first or torrential rains? Torrential rains. Obviously, volcanoes will happen first. What is Theia? Theia is basically giant Mars-sized object which underwent the collision with the planet Earth. Okay? Have anything ever directly collided with the sun? Multiple things would have collided. Multiple things would have collided with the sun, and the sun is so very hot, it will absorb everything. Okay? Right? Is any chance to create another moon for Earth in the future? No, you don't have that kind of a molten formation of the planet now. So even if there is a more collision right now, first of all, if a giant sized object like Theia were to collide now, we don't have such large objects moving around in the Earth's orbit. So if let's suppose tomorrow you wake up to the news that a giant object of this size is colliding to the planet, moon will be the last of your concern. Survivability will be the first concern. A much smaller object or an asteroid, when it collided with the planet 65 million years ago, it meant a mass level of extinction. Lot of species, they went extinct. Okay, is that understood? Eruption of a volcano is due to the earth core is molten? No. Right? Earth still attracting any material in the universe? So I think now you have got it. Now these are luxurious questions out there. Earth is still attracting. So Earth has got its gravitational pull, but the greater amount of gravitational pull in the solar system is exerted by the sun. So that is where it is the sun which keeps on attracting the materials. Okay, what is Thea made of? Thea was at that point of time also made up of molten materials. That is what even Thea was made of that. Okay. Yes, Madhur, that is how moon was originated. All the planets, majority of the planets have observed this accretionary method of formation. Heat was already exist before collision. What is heat? Heat was already exist before collision. What is the meaning of heat in this case? You have asked this multiple times. Can sun in future become a planet? I will repeat, I will reiterate the question. Can moon in future become planet Earth? Can that happen? Never. Sun is a source of production of energy. Here you don't have the production of energy. All the planets move around the sun. Sun will move around what? Sun is a star. A star is different from a planet. A planet is different from a satellite. Okay? Yes, sun can become a dead star. Okay. So now we take a break. In NCRT, it is given Earth was formed 4.6 billion years ago. Everywhere it is assumed 4.5 billion. But trust me, write it in a stamp paper. UPSC is never going to ask you a question whether it was formed 4.4 billion years ago, 4.5 billion years ago, 4.6 billion years ago, or 4.3 billion years ago. First of all, that is immaterial, because 4.5 or 4.6 billion years ago, that hardly makes a difference, but in majority of the cases you will find the estimate is 4.5. Having said that, even if you write, let's say 4.2, nobody will deduct your marks. Okay, I hope I'm making that clear. Okay, shape of Earth as observed from the space will be a kind of a geoid. The same process can't be applied to moon. What same process? Volcano and rain? No, because moon is much smaller for that, very light for that. Okay, so that is basically the aspect. Now we will be dealing with the interior, but before that we take a break. So we take a break for how much time? 10 minutes. And we are going to be back in 10 minutes, and then we are going to continue. Okay. A confirmation about the audio, please, guys. If the audio is available and is clear. Thank you. So now we talk about the interior of the planet Earth, the interior structure of planet Earth. So when we talk about the interior, you have to understand that planet Earth, if you think about the entire structure of the planet, it resembles quite significantly to that of a coconut. If you think about a ripe coconut, when you take a look at it, the outer surface is very, very hard, right? Then the inner surface, that is also solid, is a bit condensed form, and then the innermost is fluid. Something very similar is that observed in the case of the planet Earth as well. Now, how do we get to know what is present in the interior of the planet? Obviously, nobody has the wherewithal or the technological prowess to go to the center of the Earth. The deepest hole that mankind has ever dug, that deepest hole is also only around 12 kilometers deep. So the radius of the planet is close to around 6,400 kilometers from the surface. So we can never end up digging to that depth. So that is why basically we are reliant on various different sources of information which give us an idea about the interior of the planet. So here, overall, the structure of the planet can be classified into the outermost surface, that is referred to as the crust. The middle portion, which is the condensed solid, dense solid, that is what is referred to as the mantle. And the innermost portion, which is very heated up in a kind of a molten state almost, that is referred to as the core. So you have the crust, the mantle, and the core. That is what dominates or constitutes the entire planet. Now, how do we get an information about what is present in the interior? So this is based on the sources of information. The sources of information they are classified into direct sources and indirect sources. So what are the direct sources which give us an idea? Direct sources mean they will give us a first-hand information about what is present in the interior. So these are of two types. One is mining and digging activities. Mining and digging. But here also the source of information is limited. It is restricted. Because as I told you, the deepest hole dug by mankind is present in the northern region of Russia, what is also referred to as the Kola Peninsula. So that is where you have the deepest mine, which is only around 12 kilometers deep. And that has not been functional for a long period of time. It was an old mine which was abandoned very quickly because the temperatures were so very high. People started dying, right? The water would evaporate at that depth itself. So that is why even that depth was basically abandoned. So you have a limited set of information that is emitted by mining and digging. Then you have the second direct source, that is volcanic eruption. Volcanic eruption. Right? When you have volcanic eruption which occurs, materials from the interior of the planet, they rise to the surface. So by studying those materials, we get an idea about what are the conditions which are present in the interior. We get an idea about what is the temperature which is present in the interior. what is the density of materials which are present in the interior. So we get that idea with the help of the volcanic eruptions. Now, both these, that is mining and digging as well as volcanic eruptions, they have indicated to one particular aspect or a trend, that the temperature starts to increase as we move into the depth. Okay, the temperature starts to increase as we go into the depth, and that increase of temperature, that is also what is referred to as geothermal gradient. Geothermal gradient, that is increase of temperature with the depth. With depth. That is what is referred to as geothermal gradient. Generally, it is observed that the temperature starts to rise by around 20 degrees with 1 kilometer depth that you go. But that is also not fixed everywhere. This is variable. In certain areas, the rise in temperature is sharper. At certain depths, it is not that sharp anymore. Then we have the indirect sources. That is, those sources, by analyzing those sources, we get a clue about what is present in the interior. One of the biggest indirect sources of information is basically the study of the seismic waves. Seismic waves are the energy waves which are generated whenever you have earthquakes. So that energy waves, they travel through the interior. So by analyzing those waves, we get an idea about the region that they have come through. So seismic waves. Then after that, you have the condition of the study of meteorites. Now, meteorites are those tiny objects which move around the space. Sometimes they crash on the Earth's surface, they collide on the Earth's surface. So, by study of the meteorites and the asteroids also in general, that gives us an idea about what would be the materials which would be floating around the solar system at the time when this collision would have happened, at a time when this formation of the planet would have happened. So this helps us understand the state of the early solar system. That is done by the meteorites. Then, gravitational and magnetic analysis. Gravitational and magnetic field. Now, the study of the gravitational and the magnetic field, that gives us an idea that is there an anomaly? Is there any kind of differentiation in terms of the surface? Because when we take a look at the planet and the surface of the planet, the shape of the planet, we have known that the shape is a geoid, that it is slightly bulged or protruded around the equator and is flattened around the region of the poles. We do know that, isn't it? Now, what does that mean? It basically means that around the equator, if I have this as the shape of the planet, let us assume the shape of the planet is indicated like this, slightly bulged around the region of the equator. Now, what does that mean? That means here the radius will be slightly more as compared to the radius around the poles, isn't it? Radius at equator will be slightly greater. That means the gravitational effect will be slightly lesser at the equator as compared to the polar region. So by study of this, we get to know about the shape and also the interior composition. After all, when we say the magnetic field of the planet, Now, Earth also behaves like a magnet. And why is that the case? That is because of the core. The core, which consists of the molten materials such as iron and nickel, that core is able to subtend a magnetic field. But how? So basically, if you think about it, the region of the outer core, that outer core is in liquid state. Now, liquid state at a very high temperature means, in this case, if I have to draw the planet, let's suppose, Ashwant, the deepest mine is present in the Kola Peninsula. Kola Peninsula is in the northern part of Russia. That is where you have the Kola Peninsula. If let's suppose this is the region of the core, outer core, which is in solid, liquid state. Now, as this rotates, the planet as it rotates from west to east, the liquid portion of the core, that will also be rotating, isn't it? Now, the portion of the core consists of what? Consists of iron and nickel. Now, these are magnetic materials. Now, when they are at very high temperature, oftentimes you have electrons which will escape or which will be added. So that means you will have charged particles of iron and nickel present in the region of outer core due to very high temperature. And these charged particles, they are moving in a kind of a circular motion. As the planet is rotating, these charged particles will also be moving in a kind of a circular motion. So that induces a magnetic field, just like it is something that generally is referred to in physics. You have the concept of a solenoid and a toroid, but we don't go into that. Just understand the basics, that when you have the charged particles, when they move in a spiral or a circular manner, it generates a magnetic field. So this also is able to generate a kind of a magnetic field all around. And the magnetic field that is generated means the planet behaves like a magnet. This is what is referred to as geomagnetism, or the magnetism induced by the Earth. So this is what is referred to as geomagnetism. Magnetism. Now, sometimes, if you think about it, if you actually get into the imagination of it, now this outer portion of core, when we say it is molten, what do you think? Molten form of iron and nickel, will it be as fluid as water, or will it exist in clumps and chunks here and there? What do you think? What is the normal perception that you get in your mind when you try to imagine? It is not fluid as water. It exists as various clumps and various different chunks. So as the planet continues to rotate, all these various different chunks, they tend to accumulate in some portion. Let's suppose that you have a significant proportion, a significant concentration of iron and nickel, which have accumulated over here. So the magnetic field, rather than having a movement from here, the magnetic field will change. So the movement of materials in the outer core means the magnetic field is prone to change. The magnetic north and the south poles, they will change. Recently, this happened in 2020, when you had the magnetic north pole that shifted from underneath the region of North America around Alaska to the region of Siberia. Because underneath, around the region of the outer core, you had a significant chunk of molten iron and nickel, which slowly and steadily they shifted ever so slightly, and that meant a shift in the magnetic field. Now, if I ask you a statement, let me write this statement down. if I ask you the statement, you have to tell about whether it is true or false. So, magnetic field of planet Earth has changed hundreds of times since its formation. A, true. B, false. I'll launch a poll. Don't write comments. I will launch a poll. I'll give you 30 seconds. Think about it. Magnetic field doesn't have a direct impact on climate change. No. Indirectly, you can relate it to it, but no. Directly, no. Very good. Majority of us have given the correct answer. That is, it has changed multiple times. Why? Because here, when we talk about it, this basically has got an impact in the sense that when the materials will tend to move, the magnetic field and its orientation can also change. This is a statement which was asked by UPSC in the prelims examination of 2018. So, if you know the basics about the formation, which UPSC doesn't tell you to go into the formation of the planet, but if you know about the formation, you will never get these things incorrect. Kumar, wind movement can be affected, I think, by the magnetic field that you are saying? No. See, there is a slight delineation or slight deviation in wind movement. That too is observed in polar areas, not in the tropical regions. And for the entire climate to change, let us come to the portion of climatology. Once we study that, you will understand that the climate is driven by multiple characteristics, and this is almost insignificant. Now here, which concept is not cleared? Okay. Since Earth keeps on rotating continuously, why it will remain stuck at one point? So as the Earth is rotating, it is not that the fluid is independent. The fluid will rotate along with it as well, isn't it? So the fluid in the interior will rotate along with it. So that is where the chunk of it is present. Now that chunk in the fluid can shift here and there slightly ever so, but it will rotate along with it. That is why magnetic field is fixed to a bit. Okay. So what is not clear is the gravitational and the magnetic field and the concept of the volcanic eruption and iron and nickel, why it is shifting, and repeat Thea. And okay, so you want me to repeat the entire class again? Okay. So here, please understand, when we talk about the aspect of the source of information, where do we get the source of information about what is present in the interior of the planet? We get an idea that in the interior, how do we get an idea about what is present in the interior? You cannot go to the depth because the radius is around 6,400 kilometers. So you cannot go to the depth of the planet, to the center of the planet. So you are dependent upon the sources of information. Sources of information are of two types: direct source and indirect source. Direct source of information, first hand, it gives you an idea about what is present in the inside. So that you get by digging and mining activities. You go to a depth and then you get an idea about what is present, what is the material density, how that changes, how the temperature changes. And you also have by volcanic eruption. During volcanic eruption, molten materials from the inside, they come to the surface. So by that also we get an idea about what is present in the interior. Then by seismic waves. Seismic waves are the energy waves generated during an earthquake. So there also we get a clue that what is present in the interior, because these energy waves would have traveled through the interior of the planet. We will study more about seismic waves also, do not worry. Meteorites, when you have objects which come and collide with the surface, or object moving around the solar system. Now these meteorites, asteroids, etc., they are basically the remnants of the early solar system. So by studying these, we get an idea about the materials which were present in the early part of the solar system, which would have collided to lead to the formation of planet Earth. Then after that, we have the gravitational and the magnetic field analysis. How? So gravitational pull across the planet is not consistent. It is slightly variable. For example, if you consider the region around equator, let's say you are standing at equator, right? And you have a friend who is standing at the region of the poles. Now at equator, the distance from the center is slightly greater owing to the shape as compared to the distance from the center at poles. So that means the gravitational pull of attraction will be slightly lower at the region of equator. The gravitational pull of attraction will be slightly higher at the region of the poles. So that helps us understand, by just studying the gravitational field, it helps us understand and decipher the shape of the planet. What about the magnetic field? Now the interior of the planet, that is the molten portion of the core, the outer core which is in molten state, that consists of iron and nickel. Now, as the planet rotates, that molten portion also undergoes a kind of a rotation continuously. Now, these are very high temperature. At very high temperature, the magnetic materials, that is iron and nickel, they are magnetic in nature. So, at very high temperature, when they rotate, they generate magnetic field. And that magnetic field which is generated, that is what is referred to as geomagnetism, or magnetic field generated by the planet Earth. So that is how, by studying that magnetic field, we get an idea about the presence of materials in the very interior. What is the constitution, what is the component of materials present in the interior. But this magnetic field also is liable to change. It is not going to be consistent in the same region. Why? Because you have massive chunks and large portions of iron and nickel which form a clump or a chunk together, and they tend to move ever so slowly, other than the rotation of the core. So that induces a change in the magnetic field, which was experienced in 2020 when the magnetic North Pole underwent a kind of a shift. Okay? Is that understood? Right? That is why rockets are launched near the equator. Rockets are launched near the equator. One of the reason is that. The second reason is that around the region of equator, you have the highest speed of rotation. So that gives the additional boost to the rockets moving around. Geomagnetism is produced by the movement of the outer core. Okay? It means now Russian region is more prone to volcanoes? Absolutely not. The volcanic eruptions that you observe, materials are not coming from the region of core. Okay, we'll come to it, where the materials come from. Where gravitational force is greater? Around the region of the poles, Jyoti. Coriolis force, will come to it. Coriolis force is not a factor in the geomorphology. It is a factor in oceanography and climatology. Okay. So here, gravitational pull will be higher at the poles because the distance is less. Geomagnetism is the magnetism or the magnetic field induced by the planet Earth due to the motion or the circular motion of the molten materials of the region of the outer core. Okay? Right? Now, after this, why gravitation pull is greater? Okay. Gravitational force is greater around the region of the poles because due to the shape of the planet, you have the condition where the distance, the radius is slightly greater around the region of equator because it is slightly bulged. and here the radius is slightly less. Gravitational force is a product of the distance. If the distance is higher, gravitational force is less. If the distance is lesser, gravitational force is more. So in this case, the distance is lesser between the center and the region of the poles. That is why there you will have a greater gravitational effect. Okay, is that understood? Shallow, within outer core, there is a chunk of iron and nickel. The entire region of core consists of iron and nickel. The entire, forget about the chunks, forget about everything else. Understand the basics. For every region of, when we talk about the core consists of iron and nickel. Now, when iron and nickel starts moving around in a circular fashion, that is able to generate a kind of a magnetic field which is induced by it. Okay. Aishwarya, what is your question? See, I'm answering as many, I'm teaching less, I'm answering more questions. So I hope now you don't have a kind of an issue that questions are not answered, because that is what we are doing. As compared to the poles, yes, gravitational force at equator is slightly less. It is not very, very significantly less. It is slightly less. Okay. Using seismic waves, can we detect there is magnetic field or not? Using seismic waves, we get an idea about the internal structure, not about the magnetic field, because seismic waves, they are energy waves. When they travel, they basically give us an idea about the densities through which they are moving through. Okay. Impact of solar inclination is a very different concept. If you are meaning solar insolation, that is a different concept altogether. Please don't mix and match the concepts here. Now, here, if we can move ahead, my question is that, is Earth blast and again seen like previously it's seen? How will Earth blast? Oh, you are asking if the Earth can disintegrate again. Nothing can be said of the future, but as the things are going, no. You cannot expect the planets to disintegrate again. Okay? Let me write it down before you guys get confused out of your skin. Geomagnetism is produced due to the motion or I will not risk this, due to the rotation of the molten outer core consisting of iron and nickel. That is why geomagnetism is produced. Okay. Now, here when we talk about the region of the core is divided into outer core and the core is divided into inner core. Outer core is something which is in liquid state. This is the region of the outer core. That is in a molten state. Inner core is in a solid state, however. Inner core, when we talk about it, that is in a solid state. Why is that the case? That despite the very high temperature, inner core is in a solid state. That is largely because of the conditions that you come across of pressure. How? Let us understand that, and why let us also understand that. So when we talk about any state of matter, if you consider, let's say here, let's say it is solid. So this state of matter basically will have molecules solid. So molecules are joined to each other, restricted to each other in general, right? Now, if you heat this solid up, these molecules, they will start getting broken. These molecules, they will break the bonds with each other. And in order to get converted into liquid, they will undergo ever so slight amount of expansion, right? So the molecules in the liquid, they are far away from each other, a bit farther away from each other. So we can conclude from this that in order to get converted from solid to liquid, materials need to expand a bit, right? That is when the molecules will be able to flow. They will have a fluidity associated as well. So in order to melt materials expand. Okay, that is a conclusion that we can make, that materials will expand when they have to melt. Now imagine a situation where you have a solid material, but from all sides you are applying pressure to it in such a manner that you are not allowing it to expand at all. You are not allowing to expand at all. So in that case, what will happen? Regardless of how much temperature that you raise it to, it will not melt because it has got no place for expansion. Similarly, when we talk about the region of the inner core, that inner core experiences pressure from top to such an extent that it has got no space to expand. It is restricted where it is in terms of its shape and size. That is why, despite the very high temperature, inner core continues to stay in a solid state. So here, basically, due to very high pressure, there is no scope to expand at all. Means it continues to stay in a solid state despite the very high temperature. That is why you will come across a scenario where the inner core will be in a solid state, but the outer core is in a molten state. So that is the internal structure of the planet. Now here, if you take a look at the overall structure, observe that the thinnest layer or the thinnermost layer that we have, that is basically solid, or that is the crust. Then you have a slightly denser but a squishy solid in a way, that is the mantle. Then you have the liquid outer core, and then you have the solid inner core. Overall, the radius is close to around 6,400 kilometers from the surface to the center. Now, here, as you move from the crust is a thinnest layer. So if let's suppose this is the crust, the surface, it is the thinnest layer, right? Now let's suppose after the crust you have the initiation of, or the presence of, mantle. Now here, in that mantle, the upper portion is solid, But at a depth of around 160 to 200 kilometers, at a depth of 160 to 200 kilometers in the mantle, here you have the presence of a semi-molten come semi-solid material, which is referred to as asthenosphere. It is like a plastic, a molten plastic of sorts. So molten plastic, you stretch it, it will get stretched. It doesn't break easily. If you deform it, it will get deformed easily. So that is present at a depth of around 160 to 200 kilometers from the surface in the region of the mantle. And that is what we refer to as asthenosphere. Right? Here you have semi-solid, plasticky. Above that, you have the mantle, which is solid, solid upper mantle. Below that also, you have the solid mantle. In between this, you have the semi-molten material, semi-molten, plasticky, semi-solid. It is not a complete liquid. It is not a complete solid. It is in between. That is referred to as asthenosphere. Asthenos. Astheno refers to something which is weak. And that is why it is named asthenosphere, because this is a region which is weak in terms of its strength. Overall, the portion of the crust and the portion beyond this, that is this particular region above asthenosphere, that is what is referred to as lithosphere. Okay. Now, why is it so that the asthenosphere is in a semi-molten or a semi-liquid state? That is because of the fact that here in this depth, at this depth, you have the presence of radioactive active materials like uranium and potassium, isotopes of potassium, potassium 40 in general. So these are present. Radioactive materials like uranium and potassium are present. Now, these radioactive materials under the high pressure and the high temperature, because here you are already at a depth of close to around 160 to 200 kilometers, 160 to 200 kilometers deep from the surface. So at that depth, the temperature will also be high, the pressure will also be very high. So owing to the high temperature and pressure, undergo a thermonuclear reaction. Thermonuclear reaction. A nuclear reaction which produces heat. That is what is a thermonuclear reaction. And that produces heat. Which melts the partially melts, not completely, but partially melts the materials in the region. That is why asthenosphere is in a semi-molten, semi-liquid, plasticky state. That is basically why you will observe that even when you have volcanic eruptions, all the molten materials that you see in the volcanic eruptions, in majority of the cases, they are supplied from the region of asthenosphere itself. So that is basically the aspect or the reason for this kind of a structure. Thermonuclear, any kind of nuclear reaction which produces heat as the end product. Okay, so write on the PPT about core is made up of iron and nickel, and then from what crust and mantle is made up of which metal. Okay, thank you for the incessant demands which have been coming in. Write this on the PPT, do that on the PPT. Once the demands and the sets are over, we will slowly and steadily continue. Just be regular, pay attention, trust me, you will not miss out on anything. Have some patience. I will talk about each and everything. Okay, just have patience. Okay, now let us take a look at these individual layers separately. So we start with basically the crust. Crust, the region that we live on, the layer that we see in our day-to-day lives. Now, when you take a look at the mountain, the rocks, the ground surface, the plateaus in front of you, you might think of them to be the heaviest materials present on the planet. And nobody can fault us because that is what we have been looking at since our very young days, since our childhood days. So we have seen them and we think that nothing can be as heavier or as denser as a mountain. But this entire crust, which extends around 30-40 kilometers underneath the surface, this is the lightest layer across the entirety of the planet. It is the thinnest layer present across the entirety of the planet. So this crust, it is brittle in nature. Brittle means what? Something which cannot get stretched or deformed. For example, this plastic pen that I have, if I exert some force, this pen will break into two. It will not get deformed. So that is being brittle. So that is the property of the crust. It tends to break very, very easily. Now, the crust basically is divided into two types. You have the oceanic crust, and then you have the continental crust. Okay. Now here, when we talk about the oceanic crust, that is present underneath the oceans. So this is not very thick. In general, the thickness of oceanic crust is around, on an average, if you consider the thickness is 5 to 20 kilometers. Whereas in the case of the continental crust, thickness is around 30 to 40 kilometers. Now, the oceanic crust is made up of different set of materials. This is a crust which is dominant in silica, magnesium in general, rich in silica, magnesium, etc. So here you will find the presence of basaltic rocks, the dark colored basaltic rocks. Basaltic rocks. And here you'll find the light colored, less dense granitic rocks. Dominant in silica, alumina in general. Right? Always understand that despite the fact that the oceanic crust is thinner, Oceanic crust will always be heavier as compared to the continental crust. Oceanic basaltic rocks are darker shallow. Oceanic crust is always heavier than continental crust. And the reason being, as the density is very high. So imagine if, let's say, you have a sheet of steel or iron, and nearby, if you keep a very thick layer of thermocol, thermocol is very thick, but which will be heavier? Iron will be heavier. Just like that, even though the continental crust is very, very thick, it is still considered to be lighter, and the oceanic crust is the heavier one because the density is higher. This is one of the points which is mentioned incorrectly in NCRT. So NCRT is also NCRT also consists a lot of mistakes, guys. So when you read the NCRTs, always keep your eyes and ears very, very much open. So this is mentioned incorrectly in NCRT. I'll tell you which portion. So the continental crust of you will observe it is thicker, but still is lighter. Why? Because the density of material is less, because it is dominated by silica, alumina, etc. Oceanic crust is dominated by the dark colored basaltic rocks. That is why it is denser. It has got magnesium, iron also, which is present in it, and this is going to be heavier. Now, in certain areas where, let's say, you have the compression of a crust, as we have observed in the region of the Himalayas. So when you have a compression taking place, in those cases, in those areas, the crustal thickness significantly tends to increase. So that is why in the regions of major mountain systems, for example, in the Himalayan region, the continental crust can be as thick as 70 kilometers, right? So that is the case of the continental crust. Now, here, continental crust composed chiefly of granite, the density of 2.7 gram per meter cube, whereas the oceanic crust, generally basaltic rocks having a density of 3 grams per centimeter cube. It is this particular portion which is mentioned incorrectly in the NCRT. NCRT flips the data pointers when it mentions this. So that is where you have to be very, very clear. Okay. Now, this crust overall ends up representing only around 1% of the mass of the planet. Okay, it represents almost only about 1% of the mass of the entire planet. The bulk of the mass is shared by the layer immediately underneath that crust. So immediately underneath that depth of around 30, 40 or 50 kilometers from the surface begins the region of the mantle. And it extends all the way till 2,900 kilometers or almost 3,000 kilometers in depth. That is where it extends up to. And here, the density starts to increase quite significantly, right? So here, basically, you will observe that this is the region of the mantle. Mantle represents around 68% of the Earth's mass. This entire stretch, that is the region of the mantle. This entire stretch is the region of the mantle, extends up till a depth of 2,900 kilometers. Here the density will be significantly higher. As you go to the lower regions of the mantle, there is so much amount of compression, so much amount of heat. It is no longer brittle at that depth. It gets deformed very easily, right? Now, just underneath the mantle, you have the portion of the core. But when we talk about the region of the mantle, we do know that in the region of the mantle at a depth of around 160 to 200 kilometers from the surface begins the region of asthenosphere. It is derived from the term astheno, which means weak. It is considered to be extending up to 400 kilometers in depth from the surface, and it is the main source of the molten material or magma that finds its way to the surface during a volcanic eruption, right? So that is the main source of magma which will erupt to the or emerge to the surface. So here, this is the source of volcanic eruption. Okay. Why the thickness of the continental crust is 70 kilometer in the Himalayan mountain region? Because it has been compressed. Any material, when you compress it, it will get thicker. That is why. Okay. As we go deeper, temperature reduces. Who told you? As we go deeper, the temperature reduces. The temperature increases, isn't it? As we go deeper into the planet, the temperature increases. Then why not ocean water is getting hotter as we go deep? But we are not going deep into the Earth's surface, are we, my dear friend? Okay, let me get one basic thing very clear. If I have this as the land area, this as the region of the ocean, on top of it, if this is the water of the ocean, the water is deep by around 6 kilometers. What is the surface? Is this portion be considered as the surface of the planet Earth, or will B be considered as the surface of the planet Earth? What do you think? What is the surface? B is the surface here. A is never going to be the surface. B is going to be the surface of the planet. So you are not digging underneath the oceans, are you? So how come we can say now about the oceans, the temperature change is determined by different factors and different conditions altogether. We'll come to it. Have patience. That is what I am telling you. Have patience. Slowly and steadily, you will understand. You told upper and lower portion of mantle is solid, then asthenosphere is in the middle portion. Here, asthenosphere is given as the, okay. Understand, my dear friend, when we say upper portion, please understand the thickness of the mantle is how much. So mantle basically, it starts to extend from very close to the surface here, from a depth of around 40 kilometers, 40 kilometers onwards. Mantle extends up till 2900 kilometers. So the thickness of mantle, if it will be correct if I take the thickness, let's assume as 2800 kilometers. If something is present in the depth of 2800 kilometers, if something is present at a depth of only 160 kilometers from the surface, will you consider it as the upper portion of the mantle, the lower portion of the mantle, or the middle portion of the mantle? What do you think? The question was asked by Vedshri. So what do you think, Vedshri? Will that be considered as the upper portion of mantle, lower portion of mantle, or the middle portion of mantle? If the depth is 2800 kilometers, asthenosphere is found in the upper region or in the depth of 160 to 400 kilometers, what will it be considered? It will be always considered to be upper portion of the mantle. So that is why it is said asthenosphere is present in the upper region of the mantle. Above that also you have solid portion of the mantle. Above, let me write it down. So these level of basic understandings, guys, if we don't have that, how are we going to understand a subject like geography? So asthenosphere is found in the upper portion of the mantle. Above asthenosphere, also we have a portion of solid mantle on top. Okay? Is that understood now? Am I clear enough in this case? Or am I creating any doubts here? Is it clear? Good. And please understand, even this PPT is created by me only. So there is no question of PPT getting into a conflict of what I am trying to say. Look at the larger picture, try to understand the larger picture. Don't get indulged or don't get tangled in small nitty-gritty of the facts here and there. Okay. Now we come to the region of the core. Now, when we talk about the region of the core is divided into two parts, that is the outer core and the inner core. The inner core is in a solid state because it doesn't have any space to expand, whereas the outer core is in a pure molten liquid state. So here, core makes up around 31% of the planet Earth. Inner core is in the solid state because of very high pressure. Due to very high pressure. And outer core is in a liquid state. The core is made up of nickel and iron, and as the outer core tends to rotate, that is what induces a kind of a magnetic field that we refer to as geomagnetism. So as the outer core rotates, rotation of outer core induces a magnetic field. That is what is referred to as geomagnetism. Okay. So that is the case of the core. Okay. Now, between each of these layers, that is the crust, the mantle, and the core, you come across something which is referred to as a discontinuity. Between each of these layers, you come across what is referred to as discontinuities. This is going to be relevant for your prelims examination. So, what do we understand by a discontinuity? So, as you start going into the depth from the surface, the material density, the particle arrangement, that begins to change due to the pressure and the temperature. So as you move into the depth, suddenly you will come across the fact or a situation that the material density, the particle characteristic, that suddenly exhibits a kind of a change. That is referred to as a discontinuity. So when moving across a depth, due to pressure and high temperature, materials density and arrangement suddenly changes. The region demarcating the change is referred to as a discontinuity. As discontinuity, and it distinguishes the layers above and below. That is what is a discontinuity. Now you have various different discontinuities which is present in the interior, which in a way they differentiate the layer above to the layer which is to be found below. For example, even in the crust being thin enough, even in the region of the crust, if you move from the surface to the bottom of the crust, you will find that there is a discontinuity. In the lower crust, the materials are much more denser, much more closely packed. So that is differentiated by a Conrad discontinuity, right? Conrad discontinuity. Then the crust and the mantle. These are different layers altogether. So that is differentiated by the Moho discontinuity or the Mohorovičić discontinuity. A Mohorovičić discontinuity, or simply put, Moho discontinuity. In geological terms, it is simply referred to as the Moho, that this event happened beneath the Moho or 50 kilometers underneath the Moho or around Moho. So Moho discontinuity refers to the discontinuity between the region of the crust and the mantle. Then even in the mantle, you have the upper mantle and the lower mantle. They are separated and differentiated by a discontinuity that is known as the Repeti discontinuity. So the Repeti discontinuity differentiates upper and the lower mantle. Then you have the mantle and the outer core getting differentiated by the Gutenberg discontinuity, because outer core is in liquid, lower portion of mantle is in a squished up solid state. Then the outer and the inner core, they are differentiated by what is referred to as the Lehman discontinuity, after the individual who actually came upon or chanced upon the discovery that the inner portion of the mantle is actually in a solid state. So based upon that, you have the Lehman discontinuity as well. So this is basically the different types of discontinuities which are there. Out of this, for your general studies prelims, you need to know all of this, but the more important ones are the Moho and the Gutenberg. These are the important ones that you need to know, that where is this discontinuity present. For your general studies, you should be aware of this. Okay? Now, another type of question which is framed in the prelims is basically about the abundance of the various minerals. Various minerals when you consider only the surface, various minerals when you consider the entirety of the planet. So if you consider, let's say, Earth as a whole, iron is the most dominant material which is present, then followed by oxygen. Now, oxygen, don't get confused that we are talking about atmosphere also. No. This oxygen that you find, that is present in the form of oxides. Present in the form of oxides in the various ores that we have. Yes. And then you have silicon, magnesium, and so on. But when you restrict your study only to the Earth's surface, then you will find that the most dominant element is oxygen, followed by silicon, because silica is very dominant both in the continental and the oceanic areas, aluminium, iron, and then calcium. Ideally, for your examination, you should be aware of the first three. The first three in chronological order, you should be aware of that for your examination purposes. This will also be relevant for your prelims. Okay, this is also something relevant for your prelims. Okay, yes, IOS, OSA, you can remember as you want. So that is the minerals present in the interior of the earth. Then we come to the portion of rocks. Now, rocks, things that we come across on a daily basis. Now, when we talk about rocks in general, these rocks are basically classified in many ways, in many categories, in many types. But the basic and the general classification and categorization is done based upon their origin, right? Based upon how do they originate, how are they formed. So based upon the formation, you have igneous, sedimentary, and metamorphic rocks. But overall, excuse me, overall, if you take a look at these rocks, these are basically aggregates of many different materials in a solidified proportion that we have. That is what is referred to as rocks in general. And they will have unique formation, unique mineral presence, the grain size. Grain size is the size of the particles of the rocks. They will, a few of them have porosity, they will allow the water to come in. Few of them, they are non-porous, few of them materials are soluble in water, and so on. They will have different characteristics. So let us analyze the basics of these rocks in a very basic level, what is required for the examination, that is the type of these rocks. So you have the types based upon their formation, right? So this is based on formation. So based upon formation, you'll find igneous, sedimentary, and metamorphic rocks. Igneous rocks are the ones which are created. Igneous means what? Something to do with fire, the event of fire, right? So when we talk about, let's say, igneous rock formations, these will be the rocks which are created or formed as a result of cooling down of lava or molten materials. So cooling down of molten materials. Now, when we talk about molten materials, here you have to understand that, let's suppose this is a volcano. We'll study more about volcano in detail. Don't worry about it. Don't become impatient. So the volcanic eruption will have molten materials which are thrown up. Now this volcanic eruption will also have molten materials which are supplied from underneath, right? It is the molten materials which are supplied from underneath, and that rises up and flows out. Now sometimes it can happen that the molten materials can cool down within the surface of the planet itself. Underneath the surface of the planet itself, sometimes it can happen that the molten materials will cool down. Sometimes the molten materials are thrown to the surface and then they cool down. So accordingly, the rocks can be created either in the interior of the surface or on the exterior of the surface. By the way, the molten materials which are present in the interior, they are referred to as magma. Molten materials which are present in the interior, they are referred to as magma. And the molten materials which come out of the surface, that is what we refer to as lava. So as long as the molten materials are present in the interior, they will be referred to as magma. So it can happen that in the interior itself, the rocks will cool down and solidify. It can happen that the rocks come out, break through the surface, and then cool down and solidify. Either thing can happen. So here, cooling down of molten materials, both lava and magma. Okay. Then you have the sedimentary rocks. We'll talk more about it. That is how the rocks of lava, how do they behave, magma, how do they behave. We'll talk about it. Sedimentary rocks. Sedimentary means something to do with sediments. Sediments are what? These are your deposits. The deposition carried out by the wind, the river, the glaciers, etc. So basically, when you have, let's say, deposits happening in a region, now these deposits, when they happen in a region, on top of them other set of deposits will happen, on top of them other set of deposits will happen. So like that, you have multiple different deposits which will happen. Let's suppose in this region you have a set of deposits, right? On top of that, another set of deposits will happen. On top of that, another set of deposits, let's say, happens. On top of that, another set of deposits, let's say, happen. Now, these depositions can be carried out by the river on its sides. These depositions can be carried out as the wind is moving. So anything can create these deposits. But once these deposits happen, eventually they will exert a weight on top of each other, right? They will exert a weight on top of each other. They will get compacted, almost cemented together, and then they will form a kind of a rock. For example, in your day-to-day life also, let's suppose you take a flowering pot, right? In your garden, in your backyard, anywhere. Let's suppose you come across a flowering pot. And let's suppose the soil that is present in the flowering pot, you leave it out without any plant, you leave it out. You leave it out in the sun for a very long period of time, maybe for 2 months, 3 months. After that, you will observe that the soil which was soft earlier now has become a hard chunk of a material. Imagine if the same thing happens for hundreds, thousands of years, millions of years. That will get solidified into a rock. So here, basically, you have the compaction. Compaction means something is compressed, compacted. Anything which is compact means in a smaller area. So compaction and cementation. That is basically what is referred to as solidification of deposits into hard rock-like substances. That is what is referred to as the sedimentary rocks in general. So that is what we regard as the sedimentary rocks. Then we have the metamorphic rocks. Metamorphic, derived from the term metamorphosis. Metamorphosis means what? Something, now this is an English vocabulary, an English term. So metamorphosis refers to something which changes its characteristic, right? So something which changes the characteristic, its nature, its form, that is metamorphosis. So when we say metamorphic rocks, these are the igneous and the sedimentary rocks, or sometimes even the other rock types. When exposed to high degree of temperature and pressure, they change their state and form to create a new rock type altogether. That is what we refer to as metamorphic rock. So here, igneous and sedimentary rocks when exposed to very high temperature and pressure condition, the form changes to create a new rock type that is metamorphic rock. Example, marble. The marble that you use for construction purposes, the marble that is used in Taj Mahal, etc., that is a metamorphic rock. So let us take a detailed look at all these three rock types. So starting with the igneous rock. Now, if you observe this image carefully, this is an igneous rock. Now, observe this image first of all carefully before going through the text. Here you will observe a uniformity in terms of the materials which are present. Very uniform. No variation in terms of the material present. Now, that means all these would have been molten and would have solidified at the same time. Now, you will observe that the size of the individual particles, the grains, they are very fine, isn't it? So, this is basically due to the cooling action. So, igneous rocks are formed through the cooling and solidification of magma or lava. Igneous rock may form with or without crystallization, without crystals, large crystals, small crystals. So here, either it can be formed below the surface, that is the intrusive rock, or on the surface, that is the extrusive rock. Intrusive, when the magma loses energy and solidifies in the interior itself, right? So this is by solidification of magma. Solidification of magma. And this is solidification of lava. Okay, that is how you have the formation or the creation of these igneous rocks, how they get created overall, right? So the cooling of magma or cooling of molten materials on the inside and the cooling of molten materials on the outside, they will happen at a different rate. I hope you understand the question that I am asking. So basically, suppose, let's say, we have two regions. So here, I have molten materials inside, which will get cooled down. And here I have the molten materials which will come out and then cool down. Let's suppose. Here the molten materials, they flow out, right? And here the molten materials are present in the inside only and they don't come out. So this is where you will find lava. This is the magma. Now in this case, which of them do you think will cool down at a faster rate, lava or magma? What is your normal perception? Which will cool down faster? Very good, correct, perfect. Lava will cool down much faster. Why? Because it will be in contact with the outside atmosphere. Atmosphere is cooler, so lava will cool down much faster. But magma will slowly and steadily continue to lose heat, continue to lose its pressure. So the cooling will be very slow. So here, cooling is very slow. Now let me ask you another question. Now, when we say the molten materials, they start cooling down, right? Means they are losing temperature. Now the molecules, as they start cooling down, they start forming crystals and crystalline structures. Crystalline structures basically means, suppose you have 4 to 5 molecules present here. Now, as they cool down, they develop that structure because they are getting converted into solid, by the way. So they need the bonds. So they develop long crystals and bonds and the various different structures along with it, right, as they cool down. Now here, if I ask you, out of the condition of A, where the cooling down is happening, and out of the condition of B, where again cooling down is happening, in which case do you think that the molecules will have the ability to form very complicated bond-like structures, a well-developed crystals and long crystal-like structure, A or B? Beautiful. Very impressive. Very good. So majority of you have given the correct answer. It will be B. It is in this case of B where you will observe that because the rate of cooling is very slow, so the molecules will be able to form bonds with various different structures in between. So that is where here you will find very large crystals. Very large crystals. The grain size will be larger. Whereas in the case of lava, the cooling of lava, because it is happening at such a quick pace, at such a quick rate, it doesn't get a chance to form many different complicated bond-like structures. So that is why basically in the extrusive igneous rocks which are created by the cooling of the lava, you'll find there are small crystals as the cooling takes place very quickly. Here are your examples of intrusive and extrusive igneous rocks. Now, igneous rocks are the first type of rocks to be created everywhere. When the planet was getting created, when the land was getting created, the first rock to be created is the igneous rock. That is why igneous rocks are also what are referred to as primary rocks. These are also referred to as the primary rocks. Now you have a basic classification of these rocks also, dependent upon the type of minerals which are present. For example, you have the classification into felsic, mafic, ultramafic. So felsic, rich in feldspar and silica, light in color. Silica and feldspar. Low density. Very light in general. Light in appearance as well. Then mafic, rich in iron and magnesium. Iron and magnesium. Dark in color. Higher density, heavier. Ultramafic, even a greater dominance of iron. Greenish in appearance almost. Very dense, very, very heavy. So this is also a classification. So anywhere where the rocks have been created, first of all, the primary rocks have been created, that is the igneous rocks. Now they have been eroded, they have been torn down to create the deposits which would have created sedimentary. Sedimentary would have gotten converted into metamorphic, and that is what has happened. Feldspar is a mineral. Okay. Feldspar is nothing but a mineral. So that is where we'll restrict the session here today. Tomorrow we will move ahead with the aspect of the sedimentary rocks, the type of sedimentary rocks, and so on. We'll restrict the session here today. I hope the session has been meaningful to you. Kindly revise this portion when you come for the sessions tomorrow. Tomorrow we will get into the areas where We will talk about the aspect of continental drift, etc. So tomorrow we will be talking about the portion of map pointing as well. After the session, I will give you some portions of map pointing. And Jyoti, yesterday I had told you that I will give you an idea about how to make notes. Let us wait for one more day. Let me cover something substantial which will be helpful in note making. So tomorrow at the end of the session, I will give you an idea about how to create notes, about how to approach maps also. Yes, Madhur, I will check it out. Thanks for pointing that out. And Priyanka, ultramafic means ultramafic. That means the mafic properties are more dominant there. So that is basically a greater dominance of iron and magnesium. Very dark, greenish in color, high magnetic property, very dense and heavy in weight. Okay, a few more questions. What causes Earth to move into ice age? Pulkit, the Earth moves into ice age because of the variation in terms of the rotation and revolution across the planet. And this was postulated by Milutin Milankovitch in what is also referred to as the Milankovitch cycle, where Milutin Milankovitch talks about the fact that the tilt of the planet is not always fixed. Every few thousand years, the tilt changes ever so slightly. Also, the orbit of the planet is not always elliptical, owing to the influence of Jupiter and Saturn. Every 1 lakh years, the orbit changes from a kind of an elliptical to a kind of a circular. So these changes which are brought about, that brings about the ice age or an increased heating or cooling. Okay. Thanks for all the kind words, guys. Uh, in recent, uh, in recent, there was a news that speed of the core is getting slowed down. What will be the impact? The impact will be a significantly variable magnetic field. So your GPS will be and the compass will be more unreliable if the magnetic field starts changing suddenly. Other than that, if there is a kind of a slowing down of the core, that means there will be a disconnect in between the speeds. So heat will be emitted, the residual heat will come out to the surface. So you will have greater amount of earthquakes, volcanic eruptions, land rising up, land sinking down. So these events will be more common. Okay. Is it possible on the Earth's surface that very high temperature and pressure together present? Yes, it can be possible. Together, in the case when you talk about, let's say, the compression of the crust which led to the formation or the creation of the Himalayas, that would mean a significantly very high amount of pressure. You have large continental masses which are compressing them. Now, at the point of compression, due to very high pressure, heat is also produced, due to which the rocks are welded together. So that is why in the Himalayas, you will find that the sedimentary rocks, they have gotten converted into metamorphic rocks. Okay, right? Please tell felsic means magma rich in silica. Okay, felsic means magma is rich in silica. You wanted me to say this, or you wanted any other question out of this? But felsic generally means magma is rich in silica. That is correct. At max, still how many kilometers can we dig? So the deepest hole is only around 12 kilometers, and there is an inability to dig beyond that because the conditions, they change. The rocks become very, very hard and dense. It is almost impossible to get through. The ice age concept, the Milankovitch cycle, is present in your additional reading materials, Bhavya. So go through it. Okay? Go through it, you will get an idea. Is universe expanding? Yes, it is. Last slide. Okay, last slide. This is the last slide. Plutonic. Basically, when you talk about the plutonic rocks, these are the ones which are formed in the interior, in the inside, nothing to do with Pluto. If the outer core would have been solid, would Earth have possessed the same magnetic field? Absolutely not. It is the fluid or the liquid outer core which rotates, which generates that kind of magnetic field. Okay. The groundwater table is present at a depth of few meters, not even in the middle of the crust, very much in the upper portion of the crust itself. Anjali, the formation of the planet is something you won't find in the books. Nisarg, you don't get mains question from the portion of universe, no. Additional reading materials are the separate PDF Anjum which is provided to you. It is an additional reading content, the PDF of all the things that have been covered and few extra concepts that you can be aware of in a detailed written format. So that is something you can always access. Okay. Discontinuity basically is the kind of that particular region or phase where you will have the change of materials as you start going into the depth. That is what is discontinuity. This is the region of discontinuity. Okay. Silt is the deposits carried out by the river. That is what is silt. Okay. What is there in additional reading material? Kindly look at that. You will get an idea. Two core, yes, Ashwant, more than sufficient. Okay, so that is where we'll restrict the session. Okay, one last question. What is the impact of Earth? Impact of Earth or impact on Earth? Due to magnetism, you have, see, the planet in itself behaves in a way where when you have the solar charged particles released by the sun, the solar flares, etc., these charged particles, they tend to accumulate around the region where the magnetic fields are coming and going. So that is where you have the solar or the northern and the southern lights that you come across, right? So also the movement of the species, the birds, that generally ends up following the magnetic fields of lines. So you have that impact created due to the magnetic field line. If outer core is in solid state, what will happen? You won't have any magnetic field of line of action. Anjali, immediately you should. So that discontinuity is a region where you have a kind of a demarcation between the type of materials found above and below it, because the condition of the materials that continues to change with the increasing pressure and the increasing temperature. Okay. So that will be all from my side, guys, here today. We meet again tomorrow. Take care of yourself. Thank you. Goodbye.